Hello guys and welcome back. Now that we've finished the instancing setup for the cloud bed, I've gone ahead and did a high-res render using the same render settings except the AA I've increased that to 4 and it took 5 minutes and 35 seconds and it used 98 megabytes. And we can see that this is very efficient technique for to keep the memory usage as low as possible, and we can fill out any space we want without going anywhere beyond above 120, maybe 140 megabyte tops, and it depends on the volume of course. In this case they're not that high res. I think each is like 200. Well, let's see the density of the resolution of the volume. I forgot that. So this one is 241 by 81. It's quite high res, and we're not intending to be very close up to these guys. So the next part is to create the floating clouds, these guys here, and I'm gonna show two different techniques. One I used and one of them I didn't end up using in these cases. So let's go back to the scene I have here, and I'm gonna show the existing setup. I don't want to waste time and recreate it from scratch, and it's very similar to the other one. It's just the way we're creating the geometry to convert to VDB volume is a little bit different. And in this case I've started off with a sphere and I added noise to that sphere excuse me, and I added even more noise, subdivided that and converted it to a volume. You can see it's a very low res volume. Sorry, for the high res, for the final version I used this voxel size, and then I scattered point in that volume just to get something randomized. And then I added a random p-scale and set the normal to 0, and I added a normal back and added randomization, so we get different random vectors. And the idea here is to copy a shape onto those points, and the shape in this case is a sphere that I added some noise to it and added some more noise to it using I believe, yeah, a very simple noise. And then we have these points, we have this mesh. I'm gonna combine them using a copy sub and copy that sphere into those points. And this looks like a cloud shape, and then I'm gonna clip it at the bottom so it's flat, and because clouds generally have a flat bottom, so this is to get that effect. And then I'm gonna convert that geometry into a volume, and for the final resolution I used 003, and for this test, for the preview, I'm gonna actually increase it a little bit more, and I'm gonna I added the VDB activate to add more boundaries, to expand the boundaries. I'm multiplying the density, and I'm adding the same noises that we've used in the other in the cloud bed. It's just different values, layering more noise, and just different combination. And then I wrote that out, and again in this case I wrote 4, but I only used 3. And the way I'm randomizing it, I'm adding I'm animating I'm animating the noise offset on the base geometry I have. So every frame is a different noise, and that way I can get any number I want of variation and just use the one I like. And in this case I ended up using this version, and this version. Cool. So the other, let me go back. I'd like to explain one more thing which will help understand the method. So basically, you create a volume, you fill that volume with points, and then you copy a geometry. So this is the starting point, and then I copied that geometry into the points, and then I convert that into volume and add noise, and this is my final result. So this is one technique. The other technique is to use the cloud noise and cloud node, and that ships with Houdini, and the cloud noise, and it's very similar to what we have done. I modeled some random shapes, took a box and randomized it, added more noise to it, subdivided it so I get something like this, and then I made 2 copies of that, just moved them, one like this and another one like this, and then I scattered a bunch of points, so I have this. And then I also created a grid at the bottom and scattered points onto it, and I combined both of them, and this is to help create a flat bottom for the cloud. And then I added a randomize function to add random scale, and I connected that with a cloud to the cloud node, and the cloud node will simply scatter a sphere volume all around. And then with this result, let me go back. With this result, we can use the cloud noise. Now this is a more expensive node, and it generates it. The way it deforms the volume is it generates an SDF and add a displacement based on that SDF. So if you have a sphere, it will push the sphere like this, and then that result will get then the SDF for that will get then computed again and pushed again. So there's like a loop inside that generates SDF and keeps pushing noise onto the volume. So you can use this technique as well, and it's very similar to the other one, but it's up to you. So here I'm using the same noise I've used in the other ones as well. So, and then I wrote that into VDV, but I didn't end up using that. I only used these for the floating high res. And I'm gonna recreate the same setup. So I'm gonna create an Arnold volume, and I'm gonna read the VDBs that we created. So I'm gonna call this that's the path to the VDBs, and I'm gonna choose density. I'm gonna set this to volume. I'm gonna go back to the test camera and hide the instancing and hide all these guys. So I only have this. And because we're using the $F the frame, if I change the frame number, we will get the 3 different versions that we've created. And I'm gonna call this Hot Cloud Arnold volume. Same as we did before. We're gonna create a shader in the shop level. So I'm gonna use this, just copy paste it, and I'm gonna call this Top Cloud. Go back to the object level and make sure that I assign that shader again. So Top Cloud, and go back. Excuse me. And I'm gonna change the density back to 1. Leave the anisotropy the same, and lower this to 0.5. And maybe we're gonna have a slightly different color. Now the reason I'd like to have a different shader for this is because the density may vary between the different setups. And if I go back here, I know that because I use the same setup for these guys, it's just different variation of the noise, the density will be relatively the same. And for these guys, their density will be relatively the same as well, but there's a very good chance that this is different than this. So we have to make sure that we tweak the shader per volume and have the result that we're looking for. So I'm gonna expand this, the render settings, change it back to 3, and include the object top cloud only and hit render. And I'm gonna, I believe I turned off the progressive, so I'm gonna use that, turn that again. Cool. I think the shader is working already on this. For a value of 1. Yeah, I think this is very nice looking already. I think I'm not gonna change anything. I'm just gonna change frame and make sure that the other volumes are rendering correctly and that the shader is behaving on them as we expect them to be. I think for these guys I'd like to make the density a little bit stronger, so I'm gonna change it to 3 and try again. Yeah, I think this will work better, and again we can always change it. So now the shader that we've set up, the shader, we're gonna go back and export this guy to as files, the same as we did with this, and then I'm gonna have an Arnold procedural node reading those as files. So we've done this before. I'm gonna do the work. I'm gonna pause here, export these guys into as file, read them back in, and then we will set up the instancing for this guy. Cool. So thanks for watching, and see you in the next video.